It's 11 o'clock, so that means that we're going to go ahead and get started with this webinar. So welcome everyone. Welcome to Purdue at Westgate webinar series. My name is Samantha Nelson, and I'm the program manager for the Purdue Foundry Westgate at the Westgate Academy. The Westgate Academy is a technology incubator, training, and office conference center. If you are familiar with the Naval Support Activity Center, Crane, Indiana, we are directly outside the gates of that naval installation. We at Purdue at Westgate strive to promote business and talent growth, and we want to help you as a startup, a small business, and academia. We strive to be that regional hub of connection and support. The Westgate Academy is a technology incubator, training, and office conference center, just as I had mentioned. Today, we are excited to be hosting live and via the web. I'd like to introduce you, Mr. Mark Collins, almost Dr. Mark Collins. So he will be graduating in May. So we want to congratulate him on his success going forward. He currently is an associate professor with the Unmanned Systems at Indiana State University. Along with being an associate professor at ISU, Mark has been developing an idea around large unmanned craft that he is going to share with us today, as well as his knowledge of the industry and FAA and what his thoughts are on future infrastructure of the industry. I have had the privilege of knowing Mark for a few years now, and Purdue at Westgate has built a great relationship with him and others from Indiana State University. We ask that you mute your microphones during the presentation, but you may leave your video on as if you would like. If you have questions during the course of the presentation, we ask that you ask them via the chat button at the bottom of your screen, and Mark will answer them after the presentation. This webinar will be recorded and will be sent to you for your reference, as well as the copy of the presentation. So with no further ado, I will hand it over to Mark.
Well, thank you, Samantha, for that wonderful introduction. And thank you, Purdue at Westgate, for hosting me. And welcome, everybody. Good morning. Big hello and shout out from Terre Haute and Indiana State University. I'd like to welcome you all here and thank you for participating. This first slide that you see is just a kind of an introduction of the content that I'm going to be going over today on advanced air mobility. I'll first start off kind of giving you an introduction about myself and Indiana State University and our path moving forward. And then I'm going to discuss what is advanced air mobility and then the roadmap, the FAA roadmap to advanced air mobility. And then we're going to discuss some markets and principles and assumptions with advanced air mobility. And then we'll discuss some of the concepts for that NASA and the FAA have come up with for ConOps for advanced air mobility, a little bit about how they're going to manage that in the future with unmanned traffic management. And then we'll discuss some of the aircraft that are being developed today, and both for large unmanned cargo aircraft and large unmanned autonomous passenger aircraft. And we'll discuss those in relation to electrical vertical takeoff and landing, electrical short vertical takeoff and landing, and electrical hybrid, and then autonomous passenger aircraft. So Samantha did a good job with that introduction. So this is me, and you know, where I went to school and a little bit of background about myself. Samantha did a good job, so thank you for that. Indiana State University has a 4-year degree program in unmanned systems. We started it in 2012. Since that time, we've expanded it, and it's grown significantly. As you can see here, there's some students in our program that participate in the AUVSI student group, and they're participating in it. And this particular team, they went to Chicago and went to the AUVSI function in Chicago. That was the team that went. That's a 30-foot trailer you see in the middle. The students are practicing search and rescue missions. We also use it for our capstone students. They are now using it in conjunction with ISU police. So that's a pretty good program. And then you see some students being trained on how to use a Phantom 4. This is our lab that we use to for our students in the Unmanned Systems program. There's some students along the left side. They're building a drone. They do that in a 300 level course. We have about 85 students in our program. We graduate between 15 and 20 per year. They're all getting high paying jobs. The demand is pretty incredible. We're seeing that employers are starting to contact us before our students even graduate. An idea of the pool of students, and most of our graduating seniors, I'm proud to say, have jobs already. So upon graduation, they'll go out in the workforce and working in fields like agriculture, infrastructure inspection, Department of Transportation, Indiana Department of Transportation, and others. This is that trailer I mentioned with our truck that we use to tow it. These are some students who participated in an internship last year. We take safety, to heart. You can see them using landing pads and vests, and we also have hats and glasses that they use. And we kind of took this from our pro flight, and using of checklists and the implementing safety into our program, just like we do with the pro flight program. Here's some other students just showcasing their Part 107 license. They get this the first semester here at ISU. And with that, a lot of the content in this presentation today I received from a couple sources. And this is one of the main sources. This is published in June 2020. Came out from the FAA Next Gen office, and it goes over the concept of operations for urban air mobility. And I'll be discussing some of those elements in the paper today. There's another paper that just came out recently by NASA in April of 2021 called Regional Air Mobility. And some of the content in this presentation today, I sourced from these two papers. And if you want more information after this presentation, you can get it from one of these two sources, and I can also share with you this presentation today. So what is urban air mobility? Well, urban air mobility, according to NASA and the FAA, Advanced Air Mobility's mission is to help develop an air transportation system that moves people and cargo between places previously not served or underserved by aviation, local, regional, interregional, urban, using revolutionary new aircraft that not only just now becoming possible. So, this presentation kind of shows you advanced air mobility is part of urban air mobility, regional air mobility, and rural air mobility. And here we can see some of the players in the market today. We have Elroy Air, who's building an autonomous cargo delivering aircraft for delivery of cargo, about 500 pounds of cargo within about 250 to 500 mile range. And then right below that, we have Joby Aviation. It's one of the leaders in this advanced air mobility industry. They have some of the most funding. They're doing some work with NASA and the FAA to integrate advanced air mobility in the national airspace. And then right below that is another ultralight from a company called Romaris Corporation based out of Ottawa. And they're converting this ultralight to fly about 500 pounds of cargo, about 1,500 miles. And then along the right side, you see a couple renderings from Nautilus and Sabrewing. Nautilus has kind of fallen off the wayside here in the last year or so. Sabrewing has stepped it up. They're looking to certify their airframe under Part 23 and then sell it to Part 135 operators. They do have several contracts with Saudi Arabian Airlines to sell over 100 of these. So they're a California-based startup, and they're using a tilt rotor ducted fan design to fly just cargo, no passengers, 500 miles or more. So some general assumptions for urban air mobility operations are short distance within and around the metro area, suburbs, exurbs, low capacity vehicles with high volumes of flight, short turnaround between the flights, close scheduling with minimal takeoff to land and route delays, and operating at low altitudes. So urban air mobility is a subset of advanced air mobility. While advanced air mobility supports a wide range of passenger, cargo, and other operations within and between urban and rural environments, urban air mobility focuses on the transition from traditional management of air traffic operations to the future passenger and cargo carrying air transportation services within an urban environment. So urban air mobility is the transportation of people and cargo in an urban area using a small electric vertical takeoff and landing type aircraft. So this next slide kind of goes over the roadmap to advanced air mobility. In 2014, and it actually started back in 2012 with the FAA Reauthorization Act. And that Reauthorization Act mandated the FAA to start integrating unmanned systems into the national airspace. And then just in 2012, they came out with the Section 333, which was one of the first regulations that allowed commercial applications of small unmanned aircraft, 55 pounds or less, below 400 feet, within the national airspace. And then back in August of 2016, we had the passing of the Part 107 remote pilot certification, which gave more oversight for commercial applications of small unmanned aerial vehicles in the NAS. And the FAA have started with this approach just because, you know, they wanted to start with a crawl, walk, run approach. So starting with smaller vehicles and then integrating larger vehicles over time as they get more experience. And then after 2018, just more recently, President Trump signed into law the FAA Reauthorization Act of 2018. This authorizes funding for the FAA through September of 2023. This is the first long-term FAA Reauthorization Act since 2012 and takes significant steps forward in continuing integration of unmanned aircraft systems or drones in national airspace. Just like the Modernization Act of 2012 mandated integration of UAS in the NAS, the Modernization Act of 2018 takes it one step further by mandating that the FAA start to authorize drone deliveries in the NAS. Since this time, we have seen 2 commercial air carrier operations start up, and that's you see pictured along the right-hand side. We have Alphabet Wing, which is now certified under Part 135 to operate air carrier cargo delivery, and they're doing that first in Virginia. And then right below that, they're doing that in Virginia with FedEx Express, CVS Pharmacy, and they're delivering, you know, small cargo packages to urban areas, residential areas in Virginia. And then along with that, UPS was also certified under Part 135 for cargo delivery. And they're doing that now out of Wake Med, Virginia. That's in Wake Med, North Carolina, excuse me, not Virginia. And they're delivering medical samples from hospitals to test sites. And they're able to fly more than one aircraft at a time beyond visual line of sight. And they're doing that in the medical campus. And they have thousands of flights under their belt. They're doing that with cargo delivery drones under 55 pounds, below 400 feet. And the lessons learned from these 2 applications will roll out nationwide in the next few years. And so they've got the Part 135, and then also most recently in August or September of last year, the FAA passed the Part 89 remote identification, which mandates that all unmanned aircraft be identified in the national airspace by September of 2023 is when all these systems have to go into effect. And this is essentially like a license plate in the sky, which gives more, it will allow commercial operators to fly closer to critical infrastructure, knowing, you know, regulators and security personnel will have better assurances that that operation's legitimate, much like the manned aircraft flying over our heads today. We can look up on FlightAware and see where they're headed, you know, the manufacturer, the owner, the operator, and some of the operations that are involved. And we're going to be able to do that with remote ID here in the future. And then the FAA updated the Part 107 regulations to what's called Subpart D under Part 107, which allows operations over people. While we can't do it today, there isn't a drone out there that's been certified to have the means of compliance to operate it, the regulations in place so that both manufacturers and regulators and industry can come up with the standards. Once they do, then we'll be able to fly over people. And you know, some of the other technologies that the FAA and industry and other stakeholders are working on, these are some of the and going more from a voice communications to a digital communication link. And we'll talk more about that in this presentation. And then, you know, having gone over and the industry fixing some of these limitations, they'll eventually be allowed to operate larger vehicles, including cargo vehicles and autonomous passenger vehicles in the national airspace, kind of the path to integration. And this slide I got from NASA, and it kind of goes over all the advanced air mobility markets, including urban air mobility and rural air mobility and regional air mobility. And you can see we're going to have a variety of unmanned aircraft operating the NAS. We're going to have smaller unmanned aircraft operating below 400 feet. We're also going to have aircraft operating in Class E airspace. And that'll be some of the urban air mobility aircraft, some of the passenger and smaller cargo aircraft going from regional centers just outside of urban areas to urban areas. And these will be short distance flights not very long from takeoff to landing, between 4 and 10 minutes max. These flights will be. And we could see some of the other operations that are happening at higher altitudes and bigger aircraft in Class A airspace, and then above Class A, again, in E airspace with high altitude, long endurance type of unmanned aircraft for communications or surveillance applications. So AAM has a wide range of markets, and some of those markets, based on research that I've done, have been some of the big markets are going to be with military to start off with, and then remote areas, ship to shore, transportation of cargo and people, emergency medical supplies, evacuations, law enforcement operations, news gathering, weather monitoring, ground traffic assessment. So kind of before we take a look at the advanced air mobility operations in the NAS, it is important to evaluate the current state of the U.S. national transportation system to help determine potential markets for AAM air carrier operations. For example, looking at trucking delays and congestion areas and determining if advanced air mobility operations should be considered as an alternate mode of transportation for those areas, such as areas where there is a need for cargo but no airports, no roadways, no railways, no waterways to deliver the cargo. Examples could include northern territories of Canada, remote areas of Alaska, or remote areas within the United States. Another benefit of the research I've been performing is that it could reveal advanced air mobility niche markets and find potential lucrative AAM air carrier supply chain routes. Any disruption in the transportation supply chain caused by weather, no infrastructure, poor infrastructure, trucking congestion, or driver shortages could be possible market opportunities for LUCA air carrier operations. And along the left side, the figure along the left side shows kind of a concentration of those states that have the highest road congestion. And as you can see, Texas and California and New York and Illinois are some of the leaders. And here is an illustration of that. According to the American Trucking Institute of 2018, they haven't come out with a new report, otherwise I would have presented it, but trucking delays equate to nearly $1.2 billion of hours of lost productivity, and also equates to 425,533 commercial truck drivers sitting idle for a working year. And as you can see, those states with the biggest road congestion include Texas, Florida, California, Illinois, New York, Pennsylvania, Tennessee, Ohio, North Carolina. We don't have that in Indiana, but right in Illinois, if you ever been on 94 or 294, you know what I'm talking about. Just to go a half an hour or 30 miles can take you over an hour, and that's that equates to money. So a lot of money being lost. So the most common mode for shipping cargo is by truck using the national highway system. The costs are going up and delays are getting worse. Billions of dollars are required to improve access and throughput, otherwise disruptions in the shipping will continue. However, this doesn't mean that trucking shipping mode will be the best solution. It is predictable from looking at the cost of highway congestion by state, that's in the figures here, that LUCA air carrier operations would be commercially viable transportation mode starting in the states with the highest cost due to congestion. When comparing the economic potential of LUCA air carrier operations to other shipping modes, stakeholders should consider both transportation time and cost. Based on previous research that I performed and research that Platform Unmanned Cargo Aircraft has performed, the operating cost for LUCA will be lower than current air cargo transportation costs, but more than other transportation shipping modes like trucking, water, train, or pipeline. However, the shipping time LUCA takes for cargo to reach its final destination is forecasted to be less than any other shipping modes. In today's market, without considering LUCA as one of the shipping modes, transportation cargo by air is the most costly but the fastest way to get your cargo to its final destination. Stakeholders have to weigh the cost of transportation with time and make a decision how they will ship their cargo. If air cargo cost can be reduced by 30 to 40%, then this will drive the LUCA market to expand. For example, stakeholders will have the ability to use LUCA instead of manned air cargo or in situation where trucking takes too much time. So the figure 4 on the right-hand side is transportation mode trade-offs for transportation time versus cost. The size of the oval shown in the transportation mode in this figure represents the proportional dollar value of the cargo being shipped in the United States in 2018. As we can see, truck has the biggest oval and it encompasses the biggest shipping mode. Multiple modes just means that it's gone, say by water or truck or train, and then back to truck to your final destination. And then you could see the red oval for LUCA. That's kind of where I forecast that the cost, will be much lower than air cargo operations, but the time it'll take to deliver the cargo from point A to point B will be much less. So that's where I kind of see the market for large unmanned cargo aircraft. Now, going back to our regional airports, the federal, this back in the early 1950s, when the Federal Airport Act, that allowed for the construction of some 6,000 airports. That act helped foster the growth of the air transportation by providing as many people as possible with convenient access to travel. An airport is now only just about 16 minutes away from the average American. A recent paper from NASA suggests that the smaller local airport you may not have previously known existed will soon be a catalyst for change in how you will travel. Regional air mobility seeks to fundamentally change how we travel by bringing the convenience, speed, and safety of air travel to all Americans, regardless of their proximity to a travel hub or urban center. And these little dots indicated on this, in the United States are all these regional airports that are built across the United States. So regional air mobility will increase the safety, accessibility, and affordability of regional travel while building on the extensive and underutilized federal, state, and local investment in our nation airports. And most people, just like I was saying, just live within about 16 minutes from an airport. 1.6% of all trips between 50 and 500 miles are just taken by air, so only 1.6%. There's over 5,050 underutilized public use airports. While we have all those airports and the FAA are continuing to fund it with $3.2 billion in annual grant funding to these local airports. And just despite that, only 0.6% of the US airports currently support 70% of the domestic air travel here in the United States. So this is kind of showing a representation of what airports might look like in the future: vertiports, drone ports, and aerodromes. And you can see one built, on top of a building close to an airport. And stakeholders are considering building these now, which is kind of exciting. So regional air mobility's vision is to make these local airports the community hubs they were always meant to be. And innovative aircraft operational models and infrastructure are the keys to making it happen. If an affordable, efficient, robust, and environmentally friendly aircraft network were implemented across these thousands of airports, more people would be able to choose convenient air travel over cars for mid-distance trips around 50 to 500 miles. Regional air mobility's vision is to make these local airports the community hubs they were always meant to be. And innovative aircraft operational models and infrastructure are keys to making that happen. And here are just some examples of some of those aircraft that are being developed today. That's in the general aviation air taxi market, electrical vertical takeoff, the small commuter aircraft. We're starting to see that with the Cessna Sky Carrier and the Cessna Caravan, with the conversion of those from manned aircraft to optionally piloted. And I'll talk a little bit about that in the future here. But one of the key drivers to this is reducing the cost of maintenance and overhead 30 to 40%. And that can be passed down to the travelers, the passengers, and that'll equate to making the cost of transportation much less today. And that's, mainly by electrifying the aircraft and removing that pilot, we can reduce some of those costs. And electrifying the aircraft, remove the ICE engine, internal combustion engine, which has thousands of moving parts, to relatively few moving parts, and less parts means less maintenance and less cost. So that's one of the ways the industry should be getting to that point. So these are other basic principles and assumptions that came out of that concept of operations manual. So urban air mobility will operate within the FAA regulations and technical environment that is incorporated within the NAS. They will always maintain safety of the NAS as it is today. Operators cannot optimize their own operations at the expense of sub-optimizing the environment. It's one of the key things here: in the environment, both sound, noise, and emissions, and then costs. We also see that the FAA has on-demand access to information regarding urban air mobility operations. And then here are some other assumptions. Airspace management will be structured where necessary and flexible when possible. Cooperative traffic management is conducted in compliance with a set of community-developed and FAA-approved community-based rules. The FAA can set the aircraft performance requirements in order to optimize capacity in the NAS. So that's some of the things that they're doing. In this next few slides, begin to discuss the unmanned traffic management system that they're going to be doing. And some of the key motivators here are strategic deconfliction and tactical separation occur within direct ATC involvement. The urban air mobility will establish those community-based regulations as standards for operation. NASA has developed and tested detect and avoid alerting logic for unmanned systems called Daedalus. They've made the recommendations to the FAA, and the FAA are now using those recommendations to come out with standards here in the future on detection and avoiding, kind of superseding the see and avoid regulations we see under Part 91.113. Urban air mobility aircraft operating outside of urban air mobility corridors must follow operational rules and procedures applicable to that corresponding airspace. Airspace authorization will be done by FAA service providers, much in the same way that small unmanned aircraft operators can get authorization to fly in and around airports using LANC. That's low altitude notification capability. This is, they get on a service provider website, they submit their request, and they get an authorization digitally. And this is going to be a similar process that's going to be used for the advanced air mobility market, be done through digital authorizations. Still has to be worked out and much research has to be conducted, but this is why the FAA are starting from a crawl, walk, run approach, and they started doing it with smaller aircraft with the LANC, and similar process will be used for authorizations in the NAS for larger vehicles. And here we can kind of see that. This is kind of showing how the FAA, the service providers, so like a user in the system will submit a request to go from point A to B, and they'll work with the service provider that's been approved by the FAA, and that service provider will gain access to the FAA's database to make sure that airspace is clear, and then give the authorization back through the service provider to the user in the system. The user will then have to conduct that flight at a certain time and point and be at each waypoint at that predetermined time. We could see some of those corridors in this figure. You could see, in red and yellow and blue, some of those corridors and how users would go from point A to point B. So advanced air mobility aircraft technology levels. And this is kind of going over where we're at today. We're kind of, humans with technology are within the loop. So this means human is always in direct control of the automation. So that's kind of where we're at today. And as systems and automation can improve, then the technology will take over for the human element of it. So in human on the loop is where the human has supervisory control of the automation, and the human can actively monitor the system and take control if needed. And then one of the most advanced forms of automation is where the human is just over the loop. So the human is just passively monitoring the system and is informed by the automation if and what action is required. So, this is where we're going to see, two-person cockpits, going to say one-person cockpits, and then where the human is still kind of in the loop, but that second human pilot is on the ground in a control center somewhere, and is helping that pilot in the air. And it'll eventually be a collection of pilots that are on the ground in the control center, kind of monitoring and operating a collection of aircraft over time. And the final form of that automation, is where the human is over the loop, monitoring the system. And here's some of the early to intermediate technology levels for AAM. Garmin has come out with the G3000. This is a cockpit that will probably be implemented in some of the newest and advanced air mobility and urban air mobility aircraft. The humans will probably do the manual takeoff and landing until the autopilot systems and technology is over. And then pilots will probably use see and avoid in the interim until the FAA have developed the regulations for detect and avoid. And then detect and avoid, this is kind of a representative of the dataless screen that users and remote pilots will see. The arrow in the front is a representative of the aircraft, and each ring is 5, 10, 15 miles, just depending how far. And this gives you a 360-degree view of all the objects, planes, birds, other objects that could be in airspace, and provides advisory to the pilots and recommendations to the pilots. And this is an example of a screen that might be used. And this illustration I took from the FAA, and just kind of showcases different operating environments and different types of airspace, G, E, and D airspace. And it kind of shows the corridors. As corridors are given, to even go up through the corridors, they have to pass through 400 feet into Class E airspace, get into the corridor, and they also have to, as they transition through the corridor, and they'll have to descend through that corridor down to land at a vertiport. So those are type operating environments. And as airspace becomes more and more congested, we'll see them do corridors. So initial operations of eVTOL aircraft will share airspace with other aircraft, potentially on existing helicopter routes or on early predefined flight corridors. Aircraft may fly along similar pathways simultaneously and be layered with other commercial air traffic. So pilots will need to be capable of managing flights that are in close proximity to other aircraft, and to be alert to react should other traffic deviate from their planned routes. This illustration just kind of shows you the current FAA service providers that are available today for land operations. And this will be a similar system that'll be put in place to get flight authorizations to fly in the NAS in the future. It may not be the same service providers, but these are the ones we have today. And these will support operations for planning, flight intent, sharing, strategic and tactical deconfliction, airspace management functions, and support of the off-nominal operations. So these service providers may provide value-added services to subscribe that optimize operations or provide access to supplement data for urban air mobility operations. And then you're probably wondering what's going to be the responsibilities of air traffic control. Well, air traffic control will open and close those corridors. They'll also create or tactical separation for manned aircraft from unmanned aircraft pilots and community. They'll separate those other traffic from the corridors. So once the FAA opens the corridors, urban air mobility access to approval of that airspace separation will be conducted in real time through those service providers. Air traffic control will oversee the operations, but will not give the approval to fly through that corridor. This will be done by the service providers. ATC will separate other air traffic operating and controlled airspace away from them. So that's kind of the path. Whether that happens in the future still remains to be seen. A lot of research needs to be done in this area to move from voice communications to digital communications. That's kind of a limitation right now today. We still have to operate by voice, especially if there is a deviation in the flight plan. So electric vertical takeoff and electric short takeoff the pilot functions. The pilots may be commercial pilots or drawn from fixed and rotary wing aircraft. There'll possibly be new hires trained in flying air taxi operations. For passenger carrying vehicles will be piloted until automation regulations, public acceptance, and technology has matured to allow that pilot to transition to remote operations from a control center. So flying eVTOL takeoff, UAM pilots will need additional experience to meet unique capabilities in design for eVTOL, short takeoff and landing, or conventional takeoff and landing aircraft. They'll need to navigate in a challenging traffic management environment. They'll need to coordinate with other traditional airplanes and helicopters. They'll be flying at low altitudes in changing micro weather airspace with noise abatement restrictions. They'll have to operate large amounts of takeoffs and landings in a relatively short period of time. Total flight time should be just between 4 and 12 minutes. For more advanced air mobility operator functions, those operators will get Part 135 or Part 137 authorization. It's air carrier or agricultural certification and intern. And as the aircraft get bigger and the operations get more robust, eventually be governed under Part 121 operations. And those operators will be responsible for regulatory compliance and all aspects of urban air mobility operations. They will use flight follower, kind of a glorified dispatcher, to works for the operator and fulfills normal dispatcher role. So a little bit about the community capable aircraft in this urban air mobility. And we talked a little bit about it already, but it's low emissions, low noise, sometimes steep climb and descent profiles greater than 3 degrees. That'll reduce nuisance factors to communities. These include, all these hybrid aircraft, electric VTOL, and short vertical takeoff. Aircraft propulsion can reduce environmental impact, noise, and operating costs. They'll be used for transportation of both passenger and cargo. Manufacturers are developing both piloted and eventually remotely piloted aircraft. This particular aircraft was one of the first aircraft used for optionally piloted. Only recently has the U.S. military started using unmanned aerial vehicles to fly cargo. When in 2010, the U.S. Navy contracted Lockheed Martin Corp and Cayman Aerospace to build the K-MAX heavy lift cargo helicopter. At that time, the Navy had contracted for 2 optionally piloted aircraft. They were tested in combat in Afghanistan in 2011 to fly cargo resupply missions for the Marine Corps. The K-MAX demonstrator program was a success. It was used to help keep truck convoys off the road, so to reduce the threat of improvised explosive devices. So since that time, other military LUCA have not come to market yet. It's still because of the chicken or the egg, but the commercial sector has kind of stepped up the game. And we're starting to see that with commercial companies like Reliable Robotics and X-Wing starting to convert manned aircraft to optionally, or converting manned aircraft to optionally piloted aircraft. And they're starting to do that with large unmanned cargo aircraft. And in the upper right is one of those Cessna Caravan that was converted to optionally piloted by Reliable Robotics. And they started doing this in 2017. They did it first with Cessna 172. Now they're using the Caravan. They just recently got Part 135 operations and are operating these autonomous flights with a pilot at the helm. One of the limitations of all this to get these regulations passed is the data set. So one thing, like in a manned aircraft, if you're flying and something goes wrong, the pilot can take over and land it, but they don't necessarily report that data to FAA. And that's the data set that the FAA needs to eventually approve using autonomous aircraft in the national airspace. So what Reliable and others are doing is using a pilot at the helm to take over in the event that automation fails. And then later they can record this and report it back to the FAA. And they're doing this thousands of times. They're getting the data set to eventually move that pilot to the ground. And that's kind of how Reliable and X-Wing are doing it. Some of these other illustrations you see Ramirez Corp with that ultralight aircraft, and it's very simple aircraft with no empennage, and it's using wing warping, which I thought was kind of unique. and to transport about 500 pounds of cargo over 1,000 miles. And then in the lower right-hand corner is a company that really hasn't gotten any money yet, but they have some revolutionary ideas on converting C-130s to large unmanned cargo aircraft. And now I'm going to go ahead and discuss some of the other players in this industry. One of them is a company called Elroy Air, and they're building a vertical takeoff and landing eVTOL, fixed wing LUCA, capable of delivering 250 to 500 pounds of payload to destinations 300 miles away. One advantage that Elroy has is that it's capable to end-to-end aerial cargo delivery system. This includes autonomous cargo loading, taxiing and takeoff, cruise landing and unloading the cargo at its final destination. On the lower picture, you can kind of see the cargo module that's right below the fuselage, and they're using a winch system. And they'll taxi over that cargo pod, and then the winch system will retract or lower and grasp the cargo module and then bring it up into the fuselage and lock it in place so that it can fly. And they have it designed to do that autonomously. So this is a hybrid aircraft. So and it's a vertical takeoff, 250, 500 pounds, 300-mile range, autonomous. They've received about 448 million so far. One of my favorite players in this industry is Pipistrel, and they're based out of Slovenia. They're one of the first aircraft manufacturers that have certified an all-electric aircraft. They are the first. They first did it with the EASA, European Aviation Safety Association, and then later it was approved by the FAA. And they're now selling that electric aircraft. And they have a lot of experience in this autonomous operations, first by converting manned aircraft to optionally piloted. And now they are designing an all-cargo aircraft. And this is called the Pipistrel Nuuva V300, as you can see here. And they started designing this from scratch with the idea to transport cargo, up to about 1,400 miles at a range of 1,000 pounds. They partnered with NASA on this, and you could see, at the nose of the aircraft, and they're using a fork truck. And this is kind of the whole idea is kind of a truck for the sky, and really easy to operate. And it has a revolutionary design. You can see it has a has a wing at the front of the aircraft and a wing at the back. And that allows it to have a really large center of gravity. So, they can have most of the cargo towards the aft or towards the front and still be within that center of gravity to fly. So I think it's kind of unique. And there is no stick and rudder flying anymore with these aircraft. It's all pre-programmed before the flight even happens. There is things that the controller, the remote pilot, can do from the ground to deviate. Like, for example, if there is an object or people at the destination where it's going to land, there is a downward facing camera that can see that, and they can select to land in a different location, which will move that aircraft over to the other location to land. And it'll do that just with the click of the mouse, no more stick and rudder flying. And that's where we'll see most of this automation going, where we'll lose the stick and rudder. It'll be just automation, and the users are over the loop, just monitoring those systems and changing it with click of the mouse. Here's another one of those cargo delivery aircrafts. This is a Sabrewing. I showed you a picture of it earlier. And this is called the Rhaegal. It's a new generation of aircraft, cargo aircraft. It's a high efficiency, all-weather operations with vertical takeoff and landing. It's designed to carry payloads up to 5,400 pounds, delivering 2,000 over a distance of 1,000 nautical miles, cruise speed of 200 knots. The cargo bay can easily be accessed through the nose, just like you saw on the Nuuva 300. They can use LD1s, LD2s, LD3 cargo containers, or just put on pallets. This design is pretty revolutionary. As you see, it's got ducted fans. It's going to be using a turbine, powering a generator to bank batteries. It's a hybrid type of aircraft. And they do have a prototype. They haven't test flighted it. They have received quite a bit of money, 2.8 million so far. And they have orders from Saudi Arabia Airlines for over 100 of these. And one of the biggest leaders in this market is Joby Aviation. Joby has received 1.8 billion in funding. This is the design of it. The propellers have been designed to have lower noise. The noise that a lot of these aircraft are going to be emitted are designed to be right at about the same decibel as background noise in a city. So it shouldn't be much more than the background noise. This will enable them to get in and out of areas that they couldn't get to before because of noise abatement. They have a plan to enter into service by 2024. I think that's a little optimistic because, as we know, if you're in the aviation business, the regulars tend to not move that quickly. They're taking a crawl, walk, run approach. So they expect to be in 2024. I'm not sure that'll happen, but we'll see. And another one of these major players is lithium. They're trading on the NASDAQ. They've received over 511 million in funding. They plan to service both cargo and air taxi operations. They're using a vector thrust type of propulsion. As you can see there's no propellers. So they plan to enter into service 2024. They have a couple of these already in prototype and testing phase right now. Another big leader in this market is ACHR Aviation. They've received 856 million. United Airlines has partnered with them to fly routes from like JFK to Manhattan in 10 minutes. So they have electric propulsion. It'll be planned to be piloted, entering into service just in a couple of years from now. 60-mile range, 45 decibels, 150 miles per hour cruise. And that brings me to the end of the presentation today. And here are those references I talked to you about that I've included in this report. There's some of those references. If you want the report, here's my contact information. And are there any questions regarding my presentation today?
I don't see any questions in the chat function right now. You must have done a great job of explaining everything, Mark. But if you do have questions, you certainly can ask them. We can either do it in the chat function, or if you want to ask Mark directly now, we certainly can. Or he also has provided you with his contact information, so you certainly can contact him afterwards. So anybody have any questions at this time? Doesn't seem like it. You did a good job, Mark. It's a lot of information to obtain, especially on a topic that appears to be pretty early stages of the infrastructure piece of it. And I know that Mark has been doing such a job of research in the past many years, actually, in developing this. So
Thank you.
Somebody did ask, Tim Murphy is on the line, wanted to know if you had seen the 60 Minutes this past week.
Yes, I saw it. Yeah. It was great. I enjoyed watching it. Yeah.
Nice.
And if you wanted to see it, it's available on YouTube. So
Okay.
just check it out.
And this particular webinar and the presentation, it's being recorded, so we will send it to all of you as well as the presentation. Sean Walling, who I believe is with Drone Deck, correct me if I'm wrong, Sean, I'm pretty sure, but he just said adoption is coming. So, and Nirav said great presentation. So it sounds like you did a good job, Mark. So
there's one question I see in there regarding delivery. What do you see as a split between ground and air?
Oh, I see that. Yes, right.
Yeah, it's a great question. It kind of depends on the market, and those users have to debate, time and cost to get it there. If the cost can start coming down 30 to 40%, more will probably go by air. If the costs don't come down, then they'll probably go by ground, but they'll never eliminate one or the other. There's still, the ground transportation still need to be there. It's just that LUCA, large unmanned cargo aircraft, is going to be another transportation mode that's not really considered yet. And the price point should be lower and the time should be faster.
Good. I really enjoyed the analogy of truck in the sky. I've heard a lot of different ones, but that's interesting. I think that's a great analogy. So
yeah, I got that from Pipistrel. I didn't come up with it.
Okay, okay.
Yeah, Pipistrel with the design and the Nuuva V300, that was what they wanted, be easy. Like they could shove a pallet in there, they could just shove cargo in there, they can put an LD3 container, just like you would a truck, and not really have to worry about the center of gravity. So I thought that was kind of interesting, and it makes the operations simpler. And that's another key enabler to this, is to simplify the operations, taking making flying easier. Over time, pilots will have less responsibility. We'll take away, the communications will be done digitally, and the navigation will be done by the autopilot. So that'll leave the pilot to do other things to keep safe. I don't know if that makes sense. Hopefully it does.
There's another question.
Okay.
What are the gaps as you see them between those lower cost, where we want them, and where they currently are?
Most of our airplanes have engines in them today. Just moving those engines, and if we can go to electrification of the aircraft, will simplify the maintenance operations and lower the cost. I hope I'm answering that question. I hope I answered it correctly. I don't know.
Scale, Sean Walling says scale, revenue, components, software. So those are some of the gaps and costs that. Definitely.
There's still a bunch of limitations out there. Some of the limitations are with autopilot technology, with redundancy, with C3 communications, command, control, navigation, and then also with the detect and avoid, and then also with GPS auto land, integrating GPS with auto land, and then eventually auto taxi. So some of the things, and those things we're close to coming to solutions for them, but we're not quite there. The industry is trying to figure those out, and then we'll roll it out kind of in a crawl, walk, run approach as things get figured out.
So I think there's a couple other questions in here now. So if you're talking about those specific elements and they're specifically driving the cost up, then how do we reduce them? How can they be reduced?
So Amazon is involved. They've kind of early on, like 2015, 16, and 17, we saw a lot of patents in small unmanned cargo delivery. Not so much in the larger unmanned cargo aircraft, but I'm sure they're thinking about it and automating that piece.
Hey, Sean, I know you've asked a couple different questions here. What do you want to unmute and maybe clarify a couple of things for Mark and be able to, so he can answer the question, or maybe it becomes more of a discussion, I think, because there's a couple people on here in different industries. So
Sure.
Can you hear me, Mark?
Yes, I can.
Great. First and foremost, thank you so much for the in-depth presentation. Learned a lot, and in an ever-changing space, any new information is certainly welcome, let alone great quality. So thank you. So specifically, you talk about these hurdles, and I threw in, and thank you, Samantha, for naming those out, but scale, revenue, component, software, some of the specific elements that are driving up the cost. And then you mentioned if it's a set landing location, and that's why I dropped in, such as a GPS location verified through, say, a smart mailbox technology. That way you have a specific destination for that autonomous route to end. And it's easier to streamline that process. Is that what you're talking about when you say technologies that are going to help reduce those costs, or is it that we need more scaled manufacturing, which helps drive down the costs? And that's really where I was coming from.
Kind of have a couple parts to that question. Before the flight is conducted, the pilot will pre-program the flight: takeoff location, landing location, altitude, speed, and waypoints. That'll all be requested by the pilot and command, and that'll go through a service provider, which is connected through the FAA database, and then back through the service provider to the user to get authorization. And, and that pilot will have to take off at that time and be at each waypoint and then at the destination. If there's any deviation in that flight plan, then they'll have to make that request through that same service provider. Hopefully that answered your question. And then you had another question about cost, I think. And, the main motivator for this market is reducing the cost so that we can, at least 30 to 40%, which will enable that urban air mobility and the regional air mobility to really take off. And first in cargo, then in passenger. Hopefully I answered that question.
Thank you, Mark. I appreciate you taking some time to address those.
Oh,
And
yeah.
Samantha, thank you for inviting me to come up and speak just to elaborate on them. I appreciate it.
Sure, of course, of course. Thank you. Gosh, great conversation, great questions. So
yeah. So I love this topic. So
yeah, you do a great job at explaining some things. So again, Purdue Westgate wants to thank Mark, and soon to be Dr. Mark Collins. So congratulations on that too. So
thank you.
I personally want to thank you. Like I said, we have had Mark here at Westgate do a presentation here before, and he's been involved, and ISU has been involved in various events that we have had here. So we're very, very lucky to have ISU and Mark as a partnership and build relationship with us. So thank you again. Thank you all for taking the time to come out here. The presentation and recording will be sent to you. Just also want to remind you that we do several webinars here. We also host in-person events. We do have an in-person event coming up on May 3rd. We call it the first Tuesday of the month, or News Before Brews. So around 4 o'clock in the afternoon, we have someone that comes in and speaks about a specific knowledge interest. The one that we are having on May 3rd is the Purdue Manufacturing Extension Partnership, along with a company called Elite Automation. So I believe the person's name is Malachi. He will be presenting on the topic of mobile robotics for manufacturers. So it's a networking event, it's a knowledge sharing event, and we also have some light refreshments. So we invite you to come at any time during the course of that time period and just get to know some people or get some more knowledge within that specific industry. So thank you all again for joining us. Thank you, Mark. And hopefully we'll see you soon in the near future. If not, everyone have a great rest of the week. Thank you.
Thank you. Thanks for joining us. Bye-bye.